Yes, thank you.
Happy birthday!
Happy birthday,
Thank
Yay!
you. Thank you, guys. I appreciate it.
I hope you have a really fun Advent of Code puzzle for your birthday.
Yeah, I hope so.
It's been a pretty wild ride for you the past couple of weeks. Big family event last week, birthday this week. You got Christmas in another couple of weeks.
All together, that's good. All at the same time. So
Cool. One quick announcement before we start today's puzzles. Well, not much of an announcement as a note. Let's try to keep this shorter. Our last one was an hour and 40 minutes long, so I'm sure people love listening to us jabber, but for those who don't, let's try to be sensitive and try to keep it shorter if possible. It'd be great if there was like a long format and a short format, but we're not ready. We're not there yet. Ooh, everybody's blurred now.
Yeah.
That's weird because I'm on site, so
Yeah.
I think I'm just gonna remove it.
Edges are a little off. Yeah, but you have that, pretty Scandinavian background, I think.
Okay, I will leave it then.
We get to be jealous. We're just in the office. Anyway, without further ado, let's get into today's Advent of Code. We are covering, what are we covering? I don't remember.
9 and 10.
Covering 9 and 10.
And answers for day number 4.
Okay. So without further ado, let's get into it.
Woohoo!
I will share my screen. So 9 and 10, starting with 9. The smoke basin. All right, who wants to read this one? Scott, you want to take it?
Sure, I'll go for it. Smoke basin. These caves seem to be lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, your puzzle input. Smoke flows to the lowest point of the area it's in. For example, consider the following height map: 21999433210, and so on. But look carefully at this map. We can notice a few numbers are in bold. So let's continue reading for now. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations: up, down, left, and right. Locations on the edge or corner of the map have 3 or 2 adjacent locations, respectively. Diagonal locations do not count as adjacent. I think I'm going to make a point to remember that diagonal locations do not count as adjacent. So only up, down, left, and right. In the above example, there are 4 low points, all highlighted. 2 are in the first row, a 1 and a 0. 1 is in the third row, a 5, and 1 is in the bottom row, also a 5. All other locations on the height map have some lower adjacent location, and so are not low points. The risk level of a low point is 1 plus its height. In the above example, the risk levels of all the low points are 2, 1, 6, and 6. The sum of the risk levels of all low points in the height map is therefore 15. Find all of the low points on your height map. What is the sum of the risk levels of all low points on your height map?
Okay.
All right.
So we have this like carpet of numbers, right? Put nicely all in a nice grid.
Yeah, it's a nice,
right? Nice grid.
map.
So we just need to find the lowest of the numbers. And the rules are that there can be, it seems like there can be no other lower
Lower
number
numbers.
as a neighbor, and the neighbor being the top, the bottom.
Yeah, so I would probably just check through every number and I'd point to one number, check that number, and then check all of its neighbors against that number. If it is lower than all of its neighbors, then we're going to count that as a low point. But remember too that the risk level is the low point, the value of the low point plus 1. And the risk levels is what we're going to sum up at the end.
Right.
But first we got to find the low points.
So you can probably guess that 9 is not going to be a low point.
Never.
And 0 is probably going to be a low point.
Well, it could. Yeah, 0
It doesn't
should always be a low point. What if there's like 2 zeros?
Yeah,
next to
what if
each
there's
other,
two
then?
zeros next to each other?
Are they both a low point? They
does it
can't
say?
both be. I guess it doesn't say anything about it, so I'm guessing that situation will not occur. Because usually, if there would be a situation like that, they would tell us what to do. If there are 2 adjacent low points.
Oh, very good game knowledge right there. That's true. They'll probably tell us. They have told us in the past, at least, what to do if there are ties.
Yeah.
In fact, when I look through at least my puzzle input, it was huge, but just doing a quick search on the zeros, I don't think there was any adjacent zeros. So, it wasn't.
Yeah.
So we can make those 2 assumptions at least, right? That's the small tips, I guess. It reduces the search spacing numbers, but yeah, that's the problem.
That looks like the game, like the first Windows 95 game where there was some mine. You need to
Oh yeah, Minesweeper.
Minesweeper.
Minesweeper, yeah.
Yeah.
Yeah, kind of. I actually had that thought when I was working on this puzzle too. Reminded me a little bit of Minesweeper. Actually,
Minesweeper would be almost like Sudoku mixed with this stuff, because you still have to figure out, you make guesses as to what the uncovered numbers are, right? Based on the surrounding numbers. Because the surroundings with numbers would always tell you how many bombs are around that particular one. But you're right in that it's a grid of numbers, and the numbers represent something. And what we're trying to find is the lowest numbers, I guess.
all right, should we move on to the next question?
Yeah, I think we're okay with this.
Any
Yeah?
questions on this one?
I think okay, that one. I
Clear
think.
for me, yeah.
Okay, cool. So that's day 9. Let's go to day 10.
Woo.
Mhm.
Getting closer to Christmas.
Closer to Christmas? Not yet halfway.
No,
Unfortunately.
more than a third.
So day 10, syntax scoring. Farouk, you want to take this one?
Yeah, sure. Syntax scoring. So you ask the submarine to determine the best route of the deep sea cave, but it only replies syntax error in navigation subsystem online, all of them. Lucky you. All of them,
Online, all of them.
Yeah, all of them. But, it's like
Some
insulting.
navigation system
It's like you
has a-
stop. How many are wrong? I
Every-
don't even want to like compute.
How many
Just
are right? 0.
all of them are wrong.
funny sub-navigation system. All of them, the damage is worse than you thought. You bring up a copy of the navigation subsystem, your puzzle input. So the navigation subsystem syntax is made of several lines containing chunks. There are 1 or more chunks on each line, and chunks contain 0 or more other chunks. So we have chunks inside chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of the 4 legal pairs of matching characters. So if a chunk opens with parentheses, it must be closed with parentheses. I think this first one is parentheses in English. If a chunk opens with this character, it must close with the
I
same character.
call the first ones round brackets. I call the second ones square brackets. The third ones I call curly brackets. And the bottom ones I call angle brackets. But I know that there is discrepancy on what people call these. Even Americans refer to these as different things than British people do. So,
Well,
If a
there's
chunk
chunks
opens-
everywhere. Let's just call them curved chunk, square chunk, curly chunk. And what was the last one?
I went with round, square, curly, and angle.
Angle chunk.
Angle, okay. Angle chunks. If a chunk opens with a curly, it must close with curly chunk. If a chunk opens with an angle chunk, it must close with an angle chunk, apparently. So yeah, round chunks is a legal chunk that contain no other chunks, as is square chunks. More complex but well chunks include square chunks inside round. So if we have one complete chunk inside another complete chunk, I think that entire line or mixture of chunks is considered complete.
Yeah.
One open chunk must be closed with another corresponding chunk for the pair to be complete, right? And yeah, we have different variations of complete chunks here in examples. And in our input, some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. So incomplete lines are the ones where we need more chunks for the line to complete, but we do not have any mismatching chunks. We have some missing chunks, but the ones we have are all matching. Like we need some more to complete the line, but others are corrupted. Corrupted means we have chunks which are not matching. So the corresponding pair doesn't exist in the line. A corrupted line is one where a chunk closes with the wrong character. That is where the characters it opens and closes, we do not form one of the four legal pairs listed above. Examples of corrupted chunks include square chunk with a round chunk, 3 round complete chunks inside a curly chunk, and angle chunk. Yeah, different variations. Such a chunk can appear anywhere within a line, and its presence causes the whole line to be considered corrupted. For example, consider the following navigation subsystem. We have a line of 10. We have 10 lines of chunks
inside of chunks.
Chunks inside of chunks. Some of the lines are not corrupted, just incomplete. You can ignore these lines for now. The remaining 5 lines are corrupted. So if you take the first one, for example, we have somewhere inside the line, we have a chunk expecting a square chunk, but we are getting a curly chunk instead. And that makes the entire line corrupted. The remaining 4 follows the same pattern. We have a mismatching chunk to complete the missing chunk. So as we go along the lines, we can stop at the very first incorrect closing character on each corrupted line. So once we get the mismatching chunk, the chunk which makes the entire line corrupted, we can stop on that character or on that chunk. So did you know that syntax checkers actually have contests to see who can get the high score for your syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. We have 3 points for the round chunk. We have 57 points for the square chunk. We have 1,197 points for the curly chunk and 25,137 points for an angle chunk. In the above example, an illegal square chunk was found twice, giving us a total of 6 points. An illegal square chunk was found once, giving us 57 points. An illegal curly chunk was found once, giving us a 1,197 points. An illegal angle chunk was found once, giving us a 25,137 points. So the total syntax error score for this file is 26,397 points. Find the first illegal character in each corrupted line of the navigation subsystem. What's the total syntax error score for those errors? So we need to find each chunk that makes the entire line corrupted and find their scores and sum them up to get our result.
Yeah.
Okay.
I kind of regret calling them chunks because there's so many chunks in our
Chunks inside of chunks.
lexicon. Yeah.
I have one gripe about the sample data that they gave here.
Okay.
Like right on the bottom of the screen right now, where it shows the lines that are corrupted and what character was wrong in that line. I wish they had highlighted the wrong character.
Yeah.
It's kind of annoying.
Yeah.
you have to search through it yourself to even find the one character that's wrong.
Right.
So yeah, if you can highlight them for the people watching, that's great.
So that one's wrong. It's
Yeah.
wrong because you have these two open and close, these two open and close, but this one is still open. And this
it's
one is
inside
still
of the angle
open.
chunk.
But it has to be complete chunks. You can't have you can't have overlapping chunks,
Yeah.
right? It has to be distinct chunks. And so that one was illegal character in that one. And then for the next one, let's see, open. I think it's
Round
this
one,
one,
wrong spot. Yeah, right there.
right? Because we opened a bunch of these. And you kind of have to unravel it in the same order, right? Because like I said before, we can't have overlapping chunks. We have to have either sequential chunks or nested chunks. The next one, open, close. I would say it's probably, oops. This one, I think is the next one.
Yeah, that looks right.
And the one after that, I believe, is going to be this one. And then the one after that.
Probably, yeah. Okay, right.
That
Yeah,
angle
maybe.
chunk right there. That
This
first
one?
one. Yeah.
Yeah.
Yep.
Yeah, so it would have been nicer if they had highlighted those for us. But,
Sure.
So Alex just went through and showed you all the ones that were wrong.
Thank you, Alex. To me, right out of the box, the problem seemed familiar because when we covered data structures in my university years, when we covered especially stacks, we had the exact same problem. The professor had to go through the exact same problem in order to explain the concept of stacks. So even in this problem, we might go through each line and keep pushing the characters into a stack, and once we get the pair, we can just pop them from the stack. So yeah, we had the same problem.
Right. It's the idea of last in,
First out. Yeah.
Actually, I had exactly the same question on lead code like a few weeks ago, but I didn't have to do the sum at the end, but it was the same with the parentheses, with the stack stuff.
Yeah, so that should at least, let you know which one is the offending one. And then once you find all the offending ones, then you have to score them.
And I think we can also kind of make a prediction on what part 2 is going to be. Because in this, it says that those lines are corrupted. So first we need to fill, I think part 1, you got to find the corrupted ones and do something with the corrupted ones. I'm guessing part 2 is going to be with the valid inputs, because that's what Santa Claus actually wants. That's what we need to help navigate our submarine is the valid inputs.
Santa Claus wants chunks, but he wants good chunks.
Hub navigation.
All right. Excuse me.
All right, so those are questions 9 and 10.
Yeah. So we good so far?
Yeah.
All right.
For me, this problem kind of seemed relatively easier than the previous ones. I don't know why. Yeah, maybe just involves calculations and counting.
Maybe because you know where to start.
Probably, yeah, probably.
Because you have already an idea like how to solve it, so maybe that's why.
Maybe.
Okay. All right. Well, if we can help you, let us know.
Yeah, don't be afraid to ask for help.
Right.
Especially just understanding how to start.
All right.
These are meant to be confusing.
Yeah, well, they're going to get even more confusing. So the more you can clarify now, I think the better it'll help you read future questions. Let's go on to answers. So we're on answers for day 4. Before we start, I'm actually going to show day 4. Let's see.
Bingo.
Yeah. Sharing and reshare. It's the screen. Yep. Wow, it's an old version of the screen. Ta-da! Anyway, C4.
That hadn't been refreshed in a while.
It's a giant squid. Oh, okay. So this is bingo.
Yeah, playing bingo with the giant squid.
All right.
Sounds like fun.
So if I remember correctly, we have to find the first winning board. There's no diagonals, which is up or down.
No
And
doubt.
then there's an order in which the numbers are called.
Up or down or left and right.
Or left
So
and
we can
right.
do vertical line or a horizontal line to win.
Right.
But no diagonals.
No diagonals. And then there's the order in which the numbers will be called. And you just need to find, in part A, you just need to find the first winning board.
Well, there's a little more to the final answer though. You have to find the first winning board, and then to get the actual answer you're going to input, you need to
Score it.
yeah, you need to add up all of the numbers on that board that have not been called, the board won, and multiply that by the number that was called when the board won.
Yep.
So in the sample input here, the total answer will be 188 times 24 to get 4,512.
Right, because 188 is the sum of all the uncalled numbers.
Yeah.
The numbers that are not in bold, for example. And so there's a bit to keep track of. There's more than just one thing to keep track of. There's quite a few.
First, we got to find the board.
First, you got to find the board. So how do we find the board? Who wants to go first?
I can go first this time.
All right.
All right, let's see some Python.
But I didn't review it before the video, so
I did because last time I was like, damn it. I was like, I thought, wait, what did I do? So I did this time, like 20 minutes.
Okay.
Gotta clean up all the profanity in my comments.
I'm wondering how much Copilot is helping Farouk with these.
Well,
What was that?
I'm wondering how much the Copilot AI thing is helping you.
Do you want me to disable it? Do you want me to disable it?
Function, Advent 2021 day 10. Oh, it's finished.
Oh, Copilot's like, oh, I already have solutions for that. Don't mind it.
Faster, Farouk, faster.
Every day, Farouk's like, yeah, I finished in one line of code.
yeah. Farouk, why are all your comments in Chinese?
Yeah, I'm sharing my screen. All right, can you guys see? Day 4.
He's trying to do that fast now. He's trying to beat me.
Oh, nice.
But I think that we need to change the way that we do it, though. I think we shouldn't compete on that, the score that you get for being the first one to finish. I think the thing that matters at the end is going to be the number of stars.
Okay. Yeah,
Like if we can finish every day, that in itself is a big feat.
Yeah.
I think there's probably going to be a few days that I won't be able to finish. Maybe there's some that you guys won't be able to finish either.
Us with kids.
Yeah. Yeah. So
Later on, it's going to be a big detriment.
getting points for being first on a weekend, like for me, Saturday, 2 o'clock ain't happening usually. Anyway, sorry for that aside. Let's see your code for.
But it might be the only way we catch up to you.
Right. So first of all, I think part 1 starts here, playing bingo. So first of all, I have my input as an array. As usual, I should have it as a so yeah, as a single array. I have it as a single array, my entire input of numbers here. So after that, I'm having the first one. So the numbers to be played are separated by string. They are all in a string and they're separated by comma. So I'm having them on a number and the rest I'm putting in a one-dimensional board. And here in that one-dimensional array, I'm converting into a 2D array. So my input is stored inside an array. Each row is stored inside an array after these calculations here. So yeah, probably as you can see here, they are all in arrays of 5 numbers. So after that, I'm starting to loop through each array, and my step is 5. I'm getting the current. Yeah, I think I'm getting the current number first, and after I get the current number, I'm starting to loop through my board. And if my current number is in that row, I'm passing that board to this check bold function which I have here, which makes my number, or which marks the number found as bold. To determine the bold, I'm adding this star to the number. So after it has been marked bold, number will have the string, will have this star next to it. For example, after the loop is done, I can print my board here. Numbers which are marked bold will have stars next to it, just like this. So my check bold function here checks columns. First, it checks the columns, just like this. If there is a 5, if all the 5 strings in that column contains a star, it means the board that wins the first has been found. So it checks the columns first for the star in all numbers. If there's a star in that number, it increments the counter. If counter reaches to 5, it will return true. And also it will check the rows for the same thing, for the same pattern in that numbers.
Right.
So after I get the bold, so it returns true or false, right? So it returns true, which means my current board chunk of that, my existing board is a list of arrays, and chunk is a 5 arrays in that entire list. So if the board has been found, I will calculate the sums of unmarked numbers in that board with this find sum function. So it will basically loop through the entire board. And if the star doesn't exist in that current number, it will sum that number up, finds the number, and after finding the sum, I will return the multiplication of the sum and current number as a result. Yeah.
All right. So clever use of that asterisk, the star.
Yeah, I like that.
Yeah, I didn't know how to make marks in bold, so instead I added the star to this strings.
Actually, yeah, I did the same, but I didn't keep the number. I just replaced it.
Oh, okay.
But how will you sum them up?
Because we don't need to sum them. We don't need to sum the one which has been marked. Is only the one which is not marked.
True.
So at the end, I just filtered the array by. I will show you after, but
yeah. So yeah, this is my approach.
I like it. It looks nice and clean.
yeah.
All right.
Right.
Quite a bit more code than days 1 and 2.
Oh, this is nothing. You had to see my next days, man. this is
we will soon enough.
I have pages.
yeah, I wonder, like, wow.
I tried, never used.
Oh man.
Stuff I used ended up only being a page, but I have pages of stuff that I tried and didn't, or it was the wrong design. But anyways, who wants to go next?
Shall I go?
Sure.
My approach is quite a bit different. Let's see if I can remember what I did. All right, I have a lot of comments in here to help me and to help you to understand what I did as well. So first, I'm just getting my data and processing it into a way that I want to work with it. So right now, I added in here what it printed out. So this is what my input looks like at this point. It's just an array of arrays. So every row in the input is its own array right now. But I wanted to process that a little bit more to make it easier to work with. So the first thing I did is I split off the top row, the order input. So that's this one is now its own new array called order. Then I separated all of the boards. So each 5 elements in this one, I split off into a new array. But then I had an idea that I wanted to roll with. So I decided for each of those boards, I wanted to get rid of the subarrays inside and just make it an array of 25 strings. So now my input is just an array of arrays of strings. So each board is an array of strings. It's just 25 strings. And I'll show you why I did that in a little bit. So now I initialized 2 variables here. First, I set my win round. So I'm going to keep track of the round that a board wins on. Then the round will be, for example, when a number is called, the first number will be round 1. The next number will be round 2 and round 3. So whenever the winning number is called, I'll keep that win round. Next, I have my winner to store the index number of the winning board, because we're going to need that later to do the calculations. And then just to make it easier for me to see, I just went and created arrays for all of the possible winning combinations. So I drew this out on paper. If we started at the top left with index 0, we move to the right, we go 1, 2, 3, 4, and we just make a bingo board that's all in order from 0 to 24. So then these would be the possible ways to win. We have our rows and our columns. And in order to be able to loop through all of those, I put them into a new array called win combos. So this just has an array of arrays with numbers in them for possible combinations. All right, now to the meat of my code. First, I started looping through the boards. So I'm going to start with the first board. I'm going to loop through it and check the numbers. So I created a temporary array here called matches. In here, I'm going to push all of the matches that we find. Next, I'm storing the highest index. So I'm going to store pretty much when that board wins. So it's a little bit different than my win round up here. Win round is going to store the lowest round for any board that wins. High index is storing the index at which that board won. All right. Now I'm getting the length of the first element in my boards because they're all going to be the same. I could also probably just put that at 25 because they are all 25 characters, 25 in length. And now I'm going to loop through the call order. So here we go. We're going to call that J. We're going to loop through those. And if the board has the called number, I'm going to add the index of that number in my board to the matches array. Do you follow? So I'm not adding the number that was called. I'm adding the index of that number on my board.
What is the order already? Sorry, I forgot.
Order is the call order. Like that the bingo master is going to be calling out the numbers.
Ah, yeah, okay,
So
okay.
the top row in the input. I just call that order. Because that's the order that they're going to be called.
Right.
All right, so yeah, so if the number that was called is on my board, I'm going to save the index of that value to my matches array. And I'm going to set the round where that was called as my high index. Next, I'm going to see if that board is a winner. So I created a variable has won and initialize it to false because I don't know that that board has won yet. So we're going to say it has not won yet. But now I'm going to check. So now I'm going to loop through my win combos array. So just to remind you, my win combos array was my array that includes all of the different ways to win. So, and I'm going to check inside of my win combos. I'm going to check every element And I'm using this cool function, this cool method here called every in JavaScript that checks if every element in that array is within another array. Well, that's one way we can use it. So I checked if every element in that wing combos subarray is inside of my matches array. So the numbers that have already been matched on that board. So, and if all of those, if pretty much we have a bingo, I'm going to set has one to true and break out of this loop. So now if there is a bingo, I can break out of the next loop too, because I don't need to keep checking numbers. I don't want to keep calling numbers if we already have a winner. All right, now that that board has one, I'm going to check if that board has won before any other board. So I'm storing, so if the round that board won is lower than the round that any other board previously has won, then I'm going to set win round to that high index. And I'm also going to store the index of the board that I was just looping through. Questions? Follow?
Mm-hmm.
All right, so now with all of that code, I should be able to get the round that my board won and the winning board. Now I just need to pretty much process that to get the sum of all of the numbers that didn't match on that board. And this one, I probably could have done it more efficiently, but I was distracted and had to keep leaving the room to take care of Harvey. So my thoughts were all scattered. But anyways, first I got the list of the numbers that were called up to the first bingo. So I took my orders array and I sliced it up to that win round. So I got only the numbers in the order array that have been called. All right, next I created a temporary counter and I looped through my numbers in my winning board. And if they're not in that winning order, so this array that I just created, if the numbers on my board are not in there, then I'm going to sum them up. And next, we just have to get that count that I just got times the last value in my winning order array. And we got our answer. All right. I'm gonna stop sharing. Any questions or still trying to process?
No, I think it's good. So you're gonna loop through all the boards and simulate the calls.
Yeah, for each board
For each board, you're gonna simulate the calls by storing the indices of matching numbers in a separate array.
Yes.
And then you're going to be using that to match against your already lookup table that you created of all the possible winning indices.
Yeah.
To figure out whether or not you have a board that wins or not. And then once you have a board that wins, you are going to.
I'm checking win one.
Win one, but you're going to check based on shrinking the list of winning numbers down to the number of numbers that already won. And then using that, you're going to check all the numbers inside the winning board to get the ones that didn't win, right?
Yeah, the numbers on that board that were not called.
Right, using the includes.
Yeah.
Good.
All right. For Alex or Alexi?
You want me to go?
Yeah, let's
Stick
go.
with
Let's
JavaScript.
stick with JavaScript for now.
Okay, it's big enough.
Let's zoom in once.
Okay.
That's better.
Okay. So for me, just space this, remove this. So I just returned two arrays here. One, actually, the first one is, if we look at the sample, it will return the number, and the second array would be all the number from the board, actually. After that, I just saved the first one into another array. I could have done, I think, differently. I could have make it better from here, but I don't know. I couldn't find the solution here, so I just did two array and then get rid of the number. So here, then after that, I unshift. So in puzzle, there is only the board left, just a bunch of number, which is actually just this in the puzzle. This one has been removed. All right. So after that, to create the board, as we know, it's 25 number each board. I just loop through and I loop through the puzzle, and every 25, I just slice and then I create the board. So I think if I do CL board, then yes, I got all the board like that after that. So what I'm doing after that is for each number, so for every one we are gonna call to try on each board, we are looping through. Then after that, we loop for every board. Then we loop through each element of the board. So after that, so once we loop through every board, we loop through a specific one. And then I just replace this element by X if this element matches the number. Okay. So if the board number, the first number is matching with the number we are looping through, then I replace this number by X. And then after that, I go, for example, to the next one. Is this matching with the one we are calling? Yes, no, X. After this one for each of them. Then I start to check if we got a winner after the fifth round, because it cannot be a winner before 5 rounds. So at the 5th round, I start to check. And so this is for the bar. So I check for the row and the column. So I just look at 0, 1 at first, 0, 2. So for the row, and then this one, it's for the column. If we got a match, then we got a winner. So the winning number, we save it. And then if we have a winning number, which at first is implemented to, it's not implemented, there is nothing. If we have a winning number, then I just check here, and then we have a winning board. Now that I'm thinking, I just look at before we started the Zoom call, I think I could actually just place this guy and this guy here automatically. Just move that there. Then comment this. So yeah, if there is a row matching or a column matching, then we got a winning number and also a winning board. So then I just break. So I get out of the for loop. Then if there is a winning number, I also break. I got out of the board, and I got out of also of the number, all the number. There's no point. Let's say if the first 5th, there is already a winner, there is no point keep going until the end if we already have a winner. So I just get out, and then after that, for the length of I just loop again through the board, and then do a sum of every number which are not marked with an X. So if there is some number which, let's say, I think I can do CL winning. Yes, you see that the board looks like that. So there is all the X. So then after that, I just loop through this board, and then just sum all the number which are not X. And then at the end, I just multiply sum with the winning number, which we save above. That's it.
I like the way you did it. Looks like a real bingo game.
Yeah. But for me, I think, yeah, this, now I realize I could have done it here instead of here. Like there is no point checking already, because we know there is already a winning number, but there is no point to do again a winning number check.
Right.
So I could have break automatically from here. And I think we could improve also the here at this point, like this. This we could have done it here, I guess, like separated already. I don't know. It's so, I always struggle to to import my puzzle. Like formatting my puzzle, it takes me always a while.
It's just formatting the data.
I'm trying to get, from the previous day, so what can I reuse? But it's still always a pain.
Yeah.
It's hard for me too, because I've been switching between my Mac and my Windows. So my imports, my rejects is at the beginning have to be a little bit different. The way that I process my information has to be different for Mac and Windows, because there's different escape characters and line breaks and stuff.
Sure.
So I can't easily switch between my two computers. I run my code on the Mac, I get the answer. I run it on my Windows, I get some different answer.
Sometimes when, for example, you format and here you just put one space and you don't have what you want, or here, put one space here and then you screwed everything.
Right.
All right, do you have any question or?
No, looks good.
Looks good.
Nice and concise as well.
Yeah. But the thing, I don't know if there is a better way. There's too many for loop in.
I do like that you have all the way through L. Loops and loops and loops.
I, J, K, and L. No, I mean, you could break out some of the loops into functions.
Mm-hmm.
But then still have loops inside, right?
Yeah.
Well, I mean, you would just,
Call the function.
yeah, you would just move the for loop into another function, so you don't have that nesting.
Oh, okay.
Yeah, I don't know. You could create recursive functions. I don't know if it'll fit in this case. I haven't really thought about it too much, but that's also one way to unravel some for loops. But it's not a win usually, because all you're doing is adding crap to the stack, the call stack. So, and more confusion sometimes down the line when stuff goes wrong. But yeah, I think, because it's a puzzle, you're going to end up with a lot of for loops, and it's fine.
Okay.
All right. Let's see what I got. We're already 30 minutes into solutions, and we've only covered the first half.
Oh, okay. Let's be quick.
So
My
I'll
part
try
two
to,
will take 30 seconds.
I'll try to keep this nice and short. Got to figure out which window has my solution. Oh, that one. Okay. All right. Get ready for some messy code. Starting with the same thing, the same way I do. I usually put my samples in the code itself, and then I just put the read underneath, but they both end up as strings, right? It's a large array of strings, whether I read it in or whether it's something I hard coded. Now I pre-process everything into a vector of boards, and I went crazy because I created a vector of a vector of a vector of a vector of strings. So essentially,
Each element is its own thing.
every board is its own thing. Every row in the board is its own thing.
And every
row, each
number.
character is its own thing.
Okay.
Yeah. So it was, I don't know if it was the best approach, but at least it gave me something that I can work with in terms of using indices instead of trying to figure out some other like creating temporary data structures. But I don't know. That's just me. It's just something I want to do. It's weird. But that's essentially what this entire fold does. It takes all my input and puts it into that format that I want. Right. I don't know how much of this is interesting to you guys, so I'm just gonna keep going because that's all it does. All it does is chop up that line so that it fits into a vector of a vector of a vector of a vector of strings, or an array of an array of an array of an array of strings. I guess, let's see. There's nothing really vital also. Oh, one thing I did do, instead of having, okay, so the reason why it's a vector of a vector of a vector of a vector of strings and not just a vector of a vector of a vector of strings, why there's one extra vector is because that array of boards, so let's say our example, for example, has 3 boards, right? And what I ended up doing was for each board indice, so board indice 1 being board 1, board indice 2 being board 2, or since they're 0 based, 0, 1, and 2. Each board actually contains 2 boards. So each board indice, like 0, contains 2 boards, the regular board and the rotated board. And the reason I rotated it so that I don't have to do columns, because my columns have been turned into rows now. So I have a regular board and I have a rotated board, so I could just do rows. So I didn't want to do columns. There was no optimization in mind, it was just laziness, like I don't want to do columns, so, or this whole columnar thing of like for loops within for loops, only doing indices and doing that. So I just decided to just rotate the board so I can just compare rows. So it's a board array, and each element in the board array contains 2 boards, the regular board and the rotated board. And each of those contains a vector of all the rows.
Okay.
And each of those rows contains strings.
Okay.
Cool.
So the rotated array is just for checking the columns.
Right.
You can just use the same logic as having check the rows.
Correct.
Okay.
And I figured there's probably not that many boards, so it's not a big memory hit to just have 2 copies of every board.
When you mean the vector is 2 point or is it 1?
Say again?
When you say a vector is 2 point in your array?
A vector? No, a vector is just an array.
Okay.
When you say vector in JavaScript, you can think of it as an array. Python, you can just think of it as a list. You know, it's the same idea. Of course, there's going to be small changes and small differences between the behaviors and the way it's stored and worked on. But for practical purposes, for what we're using it for, you know, it's just, I use it just like I would use an array.
Okay.
All right. So I have a thing called check row. We'll come back to that because it gets called. We'll come back to that when it gets called instead of trying to break it down now without context. So I have this thing where I need to find a winning board, and to find a winning board, I kept track of a lot of things because I wanted my output to be really descriptive in terms of my output. So I kept not only the winning board, but I also kept the winning number, the winning index of the board that won, the entire copy of the row that won. But I keep references. So these are the little squiggly part is references. So I don't actually store anything. It's just pointers. I have a lot of pointers that point to the ones that row, just for me being able to print out debug statements and kind of get an idea of where stuff are going. So that's why there's all these mutable variables in front that all say winning. They all point to a part of the winning board. Anyways, just like you guys, a for loop within a for loop within a for loop within, right? So first I search through all the boards, and for each board I search through board types, right? The regular board and the rotated board. And then for each of those boards, I look through all the rows. And then for each of those, I call check row, because everything is a row now for me. And the check row, now we can take a look at it now that we have a context to it. We'll essentially just take the row, and I'm going to do a for loop. So for all the called numbers, I'm going to go through each of the numbers and see how many matches there are. And then let's see, if row contains num, matches plus num. If the number matches is the same as the row length, which, it's kind of ridiculous. We all know the row length is always going to be 5, but whatever. So if we get 5 matches out of this row from the numbers that are called, then yay, we found a winning row. And then we pass back the index. Or actually the last match, but the last match is the index, where how many numbers were called before this row wall. Right. Okay. And so we have for every row how many it takes to win. And then so essentially for all of my boards, let's say there are 100 boards, for all 200 boards, right? Because the regular boards and the rotated boards, so all of those, for every row for each one of those boards, how many does it take for that row to win? And obviously the row with the least amount belongs to a board, which ends up being the winning board. And so that's what I just keep track of here. So if this row takes the least number of calls to win, then I keep track of the row, the board, type, and all that. And so I can print it out nice and pretty. But other than that, let's see, I take the score after I find the winning board, to score the winning board. I flatten the board just to make it easier to score, which just means instead of having an array or a vector, I'm going to just turn that into a vector number. So I can just do vector arithmetic or easy arithmetic. So I turn all those, I collapse all the rows into one long row, and then I convert all the strings into integers. And then after that, I remove all the numbers that weren't called, which I now thinking back, I could have probably done in another for loop up here. But that's all that this thing does, is just removes everything that was called. So it only contains stuff that wasn't called, so that I can just call sum on that entire vector, and I get my score when I multiply that by the winning number, which I had tracked way back with everything else that I had tracked.
All right.
All right. So that was my thing. So the only thing I did different from you guys is that, so I didn't have to deal with columns. I just rotated my board.
Yeah.
Cool.
All right, so we go on to part 2.
On to part 2. Oh my gosh, there's more.
Yeah. We
All right.
played bingo, we won.
So part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win.
Oh.
You aren't sure how many bingo boards a giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter how or which board it picks, it will always win, right?
Don't squid only have 10 arms?
Does that include like the pads?
I'm pretty sure all their
All their-
technical
all their-
things,
all
I'm
their
pretty sure
things?
there's only 10 for every squid.
Maybe. So in the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for a final score of 148 times 13 or 1924. So figure out which board will win last, and then once it wins, what would be its final score?
All right. So
I
part
have
1,
one question too.
now we're getting the last board to get a bingo.
Yeah.
The loser.
I still didn't understand why we have to let this giant squid win. Like, what does
Maybe if he loses, he'll get angry and wreck your submarine.
Have you seen the giant squid?
yeah, not.
He's
You ain't
just-
gonna win, man. You make it mad.
Yeah,
You're
don't
gonna
make him
lose.
angry.
I think, does it say anything else about the giant squid other than the fact that you found the giant squid?
We are just playing. We are just playing the game to waste the time, then, right?
It says it's attached itself to the outside of your submarine, so things could get dicey.
Yeah, and the first thought,
Bingo.
maybe it wants to play bingo. It's the first thought I have when a giant squid attaches to my submarine. Bingo.
I like these stories. They're ridiculous but fun.
All right.
All right, so we go on to part 2.
Yeah, so I'll share mine since I'm already sharing. Now, in the interest of time, I'm going to skip everything that's, pretty much the same. I still have my board, I still have the rotated, everything's, my input is the same. The only thing I've changed in my strategy, even my check row is the same, is that I decided to create, in order to find the last board, I decided to create a vector list array, whatever you want to call it, of all the boards and how many turns it takes for that board to win. So I need to find out how to create a list of all the boards that win, that have a possibility of winning, and how many turns it takes for that particular board to win. Because then I can find out what the last one is and save the last one. Now, the way I have it, I'm keeping track of a lot of data, again, for printing output and stuff like that. So the easiest way to keep track of a lot of data at once, of course, is objects. Right? So I can pass around objects instead of having to pass around all 6 of my variables every time I want to pass around or keep track of these. So and plus I have to keep track of more than one now. And so I decided to create an object, and for C, C++, it's structs. And so I created a struct called board, gave it the properties I wanted, and then just gave it a line for debugging. That's for pretty printing. But anyways, so I created that. Now the rest of my logic stays the same. I still keep track of winning board and winning whatnot. The only difference is that once I do find a winning board, I store it with all the same information: the board, how many it took to win, what the winning number was, what the winning row was it the regular type or the rotated type that won, and a link to the board itself. And then I add it to the list of boards that had won. So that when I'm all done, I can sort all the boards and how many turns it takes for each board to win, based on the winning index, how many it took to win. So now all the boards should be sorted by the number it took to win. Right? And I just have to take the last one. I take the last one.
Yeah.
And then I do all the same other things that I did with the last board that won, or the first board that won. I flatten it out by turning all the rows into one long array, turning them into integers, filter out the ones that are uncalled, or filter out the ones that are called, so that's only the ones that are uncalled, and then sum and multiply it by whatever the winning number is. So the logic after that is the same.
All right, that's good.
All right. So my only thing again was creating a vector or list of boards and the number it takes for each board to win, so I can later on take that list, sort it, and take the last one. All right. Next, who wants to do the next one?
Yeah, I'll go.
All right.
All right. Can you guys see my screen?
Yep.
Right. So first, I'm going to explain my logic because the code is pretty much the same. What I figured is here in my previous function, I am breaking the loop and returning the sum once I get the first winning board. But I changed that logic to continue until all the boards are won in my next function. So I am playing the game until all the numbers are played. And as the winner boards are found, I'm also pushing them into a stack. So all the winning boards are pushed into a stack one by one as they win. So as soon as the last number is played in my new function, I stop it and get the last board from that stack and calculate the sum of that last board, multiply by the last number and return it. So yeah, it's pretty much the same function. So I have a board stack variable here in my new function, part 2. So here in my previous one, as you guys can see, once it's found, I'm calculating the sum and returning it. But here, once the board is found, I am pushing that board into my stack and removing it from my list. From the, for example, here, if this board has a winner here first, I push it into a stack and remove it from here because no point in keeping it in that list. So I remove it from my list. And once my input board's length is 0, once all the boards have won, I think I'm stopping it there. Yeah, once all the boards length is 0, I'm stop it. And I'm getting the last item from my stack and returning it with the current number, because once we don't even have to play all the numbers. Once all the boards have won, we need to get the last board and multiply it by that number, which was played last. Yeah, that's the only change I had to make.
Cool.
All right.
So if all the boards didn't win,
Someone's just sitting alone in the bingo hall at midnight waiting for the next number.
I'm not sure. Well, there's no guarantee that all the boards will win.
Yeah, but according to the story, we should have to get the output, right? So I didn't consider that.
You have to get the last board that can win. that was my interpretation. So we interpreted it differently, but you were right in this case that all the boards are one. I just read it differently. I read it. That's why I did it where I only store the boards that can win.
Because if we go, every board can win.
The sample actually he filled up every number, like the sample, like if you take the sample input and then the sample input for the board, every number would be used actually. It's like everything is. So I assume also for the real puzzle that you would do the same.
In my case, I think I'm not. All the boards are not one. I don't really have a return even.
No, but still, I mean, I'm not saying you have to solve that problem. It obviously is not part of this particular problem set, but
it could have been.
Yeah, but that I'm saying is a difference between the assumptions that you had made and assumptions I had made, and that ended up being a design difference between the two of ours. The other thing is like, because I made my first I would call loop through all the boards, and then for each row I went through all the callable numbers, whereas I think for you guys, you did for all the callable numbers, you went and looked at each of the boards. It made it, I think, more efficient for you guys to not have to sort, because you would find the boards in winnable order, whereas I had to keep track of which boards would win at what point, so that I can sort them later.
That's how I did it.
Oh.
My logic, I'll explain it later, but it was pretty much the same where I went through each board and found out how long it took for that board to win.
Oh, okay.
So
and then you went and sorted them later.
Yeah.
Okay. But I like this. I like the fact that you have the array sorted or pre-sorted, because you are looping through all the callable numbers first. That's clever.
Yeah. So actually, as soon as I read the part 2, the only solution that came up to my mind was to, as soon as the board wins, store it in a different list as soon as they win. So once all the numbers have been played, or once my input board is empty, get that list and get the last board from that list, return it.
Yeah. Just a quick comment. You keep talking about stacks, but you never pop from the stack. Instead, you use the last index.
Oh, yeah. Because I'm not familiar with Python syntax that much yet, so just using the list, but what I wanted was the stack.
Right. But does Python not have a pop? I don't know.
It has a pop. Yeah, it has a pop on the list.
I would think so. It's a pretty basic function, but I don't know. There are some functions in Rust that I was like, oh yeah, they should have this, and it doesn't have this. You have to manually.
I used pop in my last in day 10, I think. So
yeah, I saw. Okay. Cool, man.
All right.
Right.
Alexei, can you go next? I'd like to go last.
All right. Part 2. Okay. So for me, it's pretty much just.
Can you make it just a tiny bit bigger? Thank you.
All right. So it's pretty much the same as the previous from the part 1. It's exactly the same, except there is an extra variable, which is an array. And then I'm going to show you. So first we get rid of the number. So this part, we save them, same into numbers array. Then we get rid of the first array. After that, I loop through every digit left here to create every single board, same as earlier. Then I loop through the number. Then after that, through all the board. Then through the specific board. If the number match the board, the
number.
Yeah, all the item in the board and the number, then we change it to an X. Then we start to check after 5 rounds. I will explain that one after. That's still a mystery for me. So if you can help me why I had to create this +1 variable. So pretty much the same as earlier. I checked if the row first here or if the column. So if I got a winner, if I have a winner, I just check in this array. So this one I created on the top. If it doesn't exist, if it doesn't exist, I mean the board, if the board doesn't exist in this array, then I'm pushing the board number into this array. Then after that, I just check if the length of this array, so all the winning board actually. Okay, every time I get a winning board, I just pushed it to this array. Then if the length of this winning board is the same as the board, which is actually all the board, then it's finished. So then we got a winning number. I just save it. Same error as before. I think this one, I could have placed it here like that. I know the winning board, that's the last one actually. Then I break my for loop. At the end, I just made this one to make it cleaner because it's quite long inside last winning board, inside last winning board at length that's -1. And then I loop through again the winning board just to get rid of the X and then sum. And that's it. Sum with the winning number. So it's exactly the same. It's just like, I think it's pretty much what Farouk did actually.
Yeah.
Is just pushing to an
Except
array every time.
Except +1.
Except the +1. Let's come back to the +1 mystery.
+1 is just a column number.
Right, but then
Start with column 1 or column 0, and then you start with column, and then the next one, and the next one. So you start with a column, and then you just go by 5, 10, because you have everything flat anyways.
But if I try to put L, which would work, right? It should be working. It's exactly the same.
Previous
And
one was L. In your part 1, it was L.
yes, it was L. And then for part 1, everything is working smoothly. But when I tried exactly the same in the part 2, no, I got totally wrong number. So I just try to create this variable and then increment it. I increment it here. And then at that point, it's working fine. Let me just get rid of this and make it entirely visible.
Yeah. Interesting.
So can you scroll down a little bit?
Yeah, like that. More.
More.
Maybe if I dezoom a little bit, just.
That's how are you getting the winning board?
The winning board here.
23.
Yeah, this one actually, I think I can place it here. Then get it here, no problem. But
line 74 now.
74.
Yeah.
So the last winning board is an array of all the boards, and you're just going to make the last one.
You got the last one, and you got the.
But the last winning board is storing an index, right?
Last winning board.
Online.
I thought it's storing boards.
Yeah.
Or-
And so you have to go back to the regular board array
Yeah.
to realize that index into an actual.
Okay. I thought the last winning board is storing the actual board. Okay. I got it.
Yeah, on line 51, where he's pushing to last winning board, just the index. All right, looks good.
And you're also assuming all the boards will win, then, right?
Yes,
This is also some.
because I checked actually, and then if I let it run, all the boards are covered by X at the end. Every board are covered by X. So it's like, I assume, it's like, yeah, for sure it's gonna be all the board winning. So that's why I went with this.
You can also just take all the winning numbers and then making sure that, like, if you have 20 winning numbers, that all the numbers between 1 and 20 are covered. It's the same thing.
Right. Yeah.
That you're not skipping numbers in your set.
Yeah.
Assuming that the maximum number in your calling set is also the maximum number in all your boards. So if you only call up to the number 20, but one of the boards has the number 32, that board will obviously never win.
Right.
Well, for that row at least.
All right.
That's it, and still mystery for this. I need to look at it like why it's like this. I don't know why. why not the L is not working. Anyway, I solved it.
Looks good. Let me go to my code. All right, let me make sure. Okay, here's my day 4, part 2. And to tell you the truth, I got really lucky on part 2 here. My logic and my code for part 1 allowed me to solve part 2 in less than 20 seconds. I had to change 2 lines. So I'm not going to re-explain everything. I'll just explain the relevant things that I had to change. So the way that I did it initially was I checked every board and got the round that that board won. And then I saved that to my win round if that round had won in fewer rounds, if that board had won in fewer rounds than the boards before it. So earlier, for part 1, I just had initialized this to a big number. So now instead, I'm initializing it to 0 because we want it to keep getting bigger until we find the board with the biggest win round. And then I had to change this line too. This before was less than or equal to. I changed it to greater than and equal to. And then I ran my code and I got the answer. So that's pretty much all. Before, my code was finding the one that had won in the fewest amount of rounds. Now I'm finding the board that won in the most amount of rounds. So yeah, luckily my logic for part 1 worked perfectly for part 2. I didn't have to change anything except those 2 minor changes. That was it. Cool. All right.
So you, in your first part, you loop through all the combinations. You don't break when you find your first board?
No.
Right. So
Because I was looking through the boards.
Right.
Not, yeah, I was looking through the boards and checking when that board wins. And then I'd save the index or the round where that board won.
Right.
If it had won in fewer rounds than any other boards before it.
Right. Okay.
So every time I found a board that won in fewer rounds, I would replace my variable with that board's.
Yeah, and I think I did something similar with mine because I do the same approach, right? I loop through the boards before I loop through the counted numbers.
Yeah.
And I think I ended up with the solution of using, because I wanted the entire package of output, all the winning stats. And so I ended up creating an object. And I was like, oh, if I'm going to be comparing objects anyway, then I might as well just save all the objects. Ended up down that path. But I guess I could have also done something similar. Cool.
Were you like me, where you'd work on it for 10 minutes, get distracted, have to go away and come back? And
yeah, I mean, it depends. If I was doing this from home, then yeah. It was either doing distracted or the kid on my lap, I was bouncing him while he was like grabbing for stuff off my desk. And I would be typing with one finger because I had the other hand, I'd be like, trying to hold him.
yeah.
So it's an adventure. Oh, we lost Farouk.
Oh no.
Oh, there's Farouk.
Okay.
All right.
I think.
Well, that should be it. We got another hour-and-a-half recording.
Oh.
I think the material is thicker, so I guess it's understandable.
If we put it on YouTube, we could create timestamps so people can just click through to the relevant parts.
Sure.
We can create a timestamp like day 9 discussion, day 10 discussion, day day 4 answers, part 1 answers, JavaScript. Like create a timestamp for each language that we use even.
Yeah. Maybe you can create a program to automatically detect whose microphone is on for the longest and assume that that person is presenting the code.
Wow, like that.
Yeah, but no.
No.
We could, but
Probably not even timestamp, like just the video.
yeah, and then we'll have like after all that effort, maybe like 3 people would watch the video. We don't want that to happen either. Anyway, yeah, so have a great weekend. We have 11, 12, and 13 on Monday that we're going to cover. And then we have day 5, which would be interesting for me to cover on Monday.
Interesting as in
like for part B, I can't get mine to run in less than a couple minutes.
Oh.
And so I'm interested to see what you guys had done.
Oh, day 5. Let me check mine real
Found
quick.
nothing for
I
me.
ran into I think I was getting some fatal JavaScript errors. No, that wasn't day 5.
Okay,
It was maybe day 6. I got fatal errors. That was a fun one.
but there's obviously a pattern that I wasn't seeing, and I wanted to see what those patterns were. So before I Google it, I want to see what you guys have, and then afterwards, I'll see what the internet says. But I was trying to keep it a nice puzzle for me to figure out. Anyway, that's it.
All right.
Hope you guys have a great weekend.
Thank
You
you.
guys too.
We will see you guys on Monday.
Take care, everyone.
Great weekend.
See you next week.
Happy coding.
Happy coding.